Roll number 11 is there. Roll number 11.
Yes, sir.
लास्ट वीक में आपका अटेंडेंस कम हुआ था.
Yes, sir. Yes, sir.
एनी रीजन मीन्स कुछ काम था.
Yes, sir. No, no, sir. I was positive, so I was in quarantine.
ओके. नाउ यू फील गुड.
Yes, sir. Yes, sir.
ओके. So what formula you get for tan theta?
1 minute, sir.
Okay, try it. So this equation you have to take.
Ax upon negative a square plus d square minus dx.
Correct. Okay. Let us verify it. So you get like this: tan theta is equal to ax upon a square plus d square. Here you get minus dx. Okay. Check. So it is your equation 5.
Sir, isn't a square supposed to be in minus?
No, it will come positive. Because here in the formula of tan alpha minus theta, your expansion will be like this: tan alpha. Here minus sign will come, minus tan theta. और यहाँ पे instead of minus plus will come 1 plus tan alpha into tan theta. It is a tan a plus b formula, and here it is a tan a minus b formula. Okay, so we check it. So
Yes, sir. Sorry, sir.
correct. So we have one equation with us of condition of correct steering. What is that? Cot phi minus cot theta should be equal to c upon b, right? ऐसे ही ना, c upon b, where c is the distance between pivot points and b is the wheelbase. So here we have the value of tan theta instead of cot theta. So we want to find out cot theta. Cot theta will be 1 by this, 1 upon tan theta. Okay, we know that for correct steering this condition should be satisfied: cot phi minus cot theta. We have seen it last time. So it can be written as 1 upon tan phi minus 1 upon tan theta is equal to c upon b. Put the value of tan phi here. Tan phi आपने calculate किया ऊपर, यहाँ पे कैलकुलेट किया, तो tan phi का वैल्यू put here, you get an equation like this, tan phi a into x, और ये ऊपर चला जाएगा a square plus d square plus dx minus, then put the value of tan theta here, a into x, this, solve this equation, ये इक्वेशन सॉल्व करो तो a स्क्वायर माइनस a स्क्वायर ये चला जाएगा, d स्क्वायर माइनस d स्क्वायर ये भी चला जाएगा, dx, और ये माइनस माइनस प्लस हो जाएगा, dx प्लस dx मीन्स 2dx, आपको मिलेगा 2dx अपॉन ax, लेट मी राइट, सो यहाँ पे आपको क्या मिलेगा, इज इक्वल टू 2 माउस इज डिफेक्टिव, 2 into dx upon a into x, like this. So this x will again get cancelled, and what will remain, d upon a. Okay, so d upon a, if you remember, d upon a is nothing but your tan alpha. अगर हम पीछे जाते हैं, ये देखो यहाँ पे tan alpha is what, d upon a. Okay, so d upon a we can keep as tan alpha, and this 2 can be sent here. So we will get a formula, tan alpha is equal to c upon 2b, c upon 2b. Okay, tan alpha is equal to c upon 2b. So it is very important equation. From this equation, what you calculate is the angle of inclination of slotted links. तो जो links slotted है, like ऐसी एक लिंक है, यहाँ पे आपने आपका व्हील है, ये स्लॉटेड लिंक है, तो when vehicle is moving straight, at that time what should be the angle of inclination, alpha, so that you can find with the help of this equation, that it should be equal to c upon 2b. Okay, you can calculate the value of alpha here. c is the distance between two pivot points, जैसे यहाँ पे है, तो ये जो पॉइंट्स होते हैं ये पिवोट होते हैं, यहाँ पे लिंक्स विल टर्न, so that distance is constant equal to c, and b is the wheelbase. Okay, wheelbase is nothing but distance between front wheel and rear wheel measured at the centers of the wheels is your b. So if you satisfy this condition and properly calculate this angle of inclination, then the Davis gear mechanism is such that it will satisfy the condition of correct steering at all turning angles. Okay, but disadvantage is that it has too many sliding members, sliding parts, and sliding motion में friction ज़्यादा होता है. That's why wear will take place, and due to wear it will lose its accuracy. Okay, after that period, okay, it will not satisfy the condition of correct steering. That's why it is not in common use. Getting this, you note down this equation for Davis gear mechanism. आपके पास वीडियोस की सारी लिंक है, watch the videos and complete your drawing sheet then only I can grant you term work for KOM, and that will also help you in your final examination. We don't have any viva or practical for KOM.
So do we have drawing in uh, exam?
No, any, yeah, in exam you will have drawing. जैसे लास्ट टाइम भी हुआ था, आपको आईसीआर पे न्यूमेरिकल आया था, तो उसका ड्राइंग बना था, ठीक है। वैसे ही आपको आईसीआर पे आ सकता है, रिलेटिव वेलोसिटी पे आ सकता है, देन रिलेटिव एक्सेलरेशन, then cam and follower. Drawing will come in exam. Have you noted down this? Tan alpha is equal to C upon 2b.
Yes, sir.
Okay. So then let us move to next. As I told you, it is not in common use. So next is the Ackermann steering gear. Okay. So first you understand its construction, that what it is made of. You can see it is very simple 4-bar mechanism, just 4-bar mechanism. Okay. So you can see that this is one link AB. So point A and B cannot move, they are fixed point. That's why this is link AB is fixed link, right? Then in front of that link CD is there, this link. So when vehicle is moving straight, then link AB and link CD, they remain parallel. These are two links. थर्ड लिंक इज दिस पिवोटेड लिंक, अगेन इन द फॉर्म ऑफ बेल क्रैंक लीवर। ये जो लिंक है ये डायरेक्ट यहाँ से आता है और इस तरह टर्न लेता है। सो ये आपका एक लिंक है, और वैसे ही यहाँ पे दूसरा लिंक इधर है, विच विच आल्सो होल्ड्स द एक्सेल। एक्सेल का पार्ट भी इसी में आता है, इस पे एक्सेल पे व्हील माउंट होता है। ओके, लाइक दिस। सो रेड में दो लिंक हो गया, एक लिंक ए बी और ये दूसरा लिंक सी डी, इन दिस वे। नाउ if you want to take a turn, what you will have to do, again you have to give the motion to link CD. Okay, but in this case link CD is not constrained to move in horizontal direction only. Okay, it can also change its angle. So say if you give motion to it, it may become like this, inclined. Okay, this point will move here and this will get rotated like this. As you are moving link CD here, point C will be here somewhere, and the right, sorry, left wheel, it will turn inside, it will turn inside like this. Okay, so it is very simple mechanism, 4-bar mechanism it is. Okay, and because of its simplicity, it is mostly used in automobiles. Okay, it don't have any sliding members, so no problem of wear and tear. Okay, construction is also very simple. Okay, but what are the disadvantages of Ackermann and how they are overcome? Okay, we will also see that. So before that I will show you its वीडियो। पहले उसका एक फ़ोटो देखते हैं। सी, here you can see that it is one link over which wheel is also mounted here. ये एक लिंक हो गया है आपका. सिमिलर यहाँ पे दूसरा सेकंड लिंक बेल क्रैंक लीवर शेप का, यहाँ पे ये वाला जो है ये दूसरा लिंक है जिसपे दूसरा व्हील माउंट है. ये 2 लिंक हो गए. ये 2 लिंक को ये लिंक सीडी से कनेक्ट कर दिया. और ये जो है इट इज़ द फिक्स्ड लिंक. पिवोट पॉइंट से जो मिलके लिंक बना है, इट इज़ द फिक्स्ड लिंक. दिस लिंक विल नॉट मूव विथ रिस्पेक्ट टू द चैसिस ऑफ द व्हीकल. ओके, सो यहाँ पे आपको ये नहीं बताया है. ठीक है, chassis is connected like this. So chassis, with respect to chassis, this link will not move, so it is fixed link. Okay, it is the one diagram of Ackerman steering mechanism. It consists of 4 bars. Okay, then I will show you the video of Ackerman. So it is the same डेविस. इसके बाद एकरमैन का एक्सप्लेनेशन शुरू होता है. ओके,
So in practice, this is not a very commonly used mechanism. Instead, people use Ackerman's linkage, which we'll see. This is Ackerman's.
see this is the Ackerman. So when Ackerman steering gear, when vehicle is moving straight, so these 2 links remain parallel like this. But here it is shown, it is given a right turn. Okay, so similarly this link will be moving like this. ये जो link है ये ऐसे मूव होगा, it is pivoted here, तो ऐसे मूव होगा. और this link it will move like this. तो ये पोजीशन से ये पोजीशन पे आता है. Okay, so here you can see that in this case the ICR does not fall at same place. जो फ्रंट व्हील का जो ICR है और रियर व्हील का जो ICR है उसमें गैप होता है. मीन्स these two ICRs are not coincident, and because of that what happens, the Ackerman steering gear mechanism does not satisfy the condition of correct steering at all the turning angles. Very it will satisfy the equation at only 3 turning angles, which we will discuss. Okay, so this condition is not satisfied for at every angle. I think power is out, but we have sufficient battery. It was on. Just a second. Okay. So as we were discussing that Ackerman steering mechanism does not give the condition of correct steering at all positions. There will be only 3 turning angles at which this condition will be satisfied, and at other angles the condition will not be satisfied. Okay, so we will see how that problem is overcome.
Steering gear. It is essentially a 4-bar mechanism with 2 bell crank levers,
The-
like in Davis steering gear.
These are bell crank
They
levers.
carry the wheel on one side and a hinge on the other. That hinge is connected to a coupler, and the whole mechanism is fixed to the chassis via these 2 dual levers. Let us see how we can steer this. So I'm going to drag on this link over here.
So you drag this link like this.
Angles like before. And if you find their point of intersection, this time you notice that it is not intersecting on
So
the rear axle.
point of intersection
These
is not
two wheels
extinct
are turning about one point.
here.
These 2 wheels are turning about an axis which is not coincident with that point. And therefore, some of the wheels, or maybe all 4, So this is not giving us the correct steering. But because all the pairs used here are revolute pairs, which can be well lubricated and which will have lesser wear, makes this more robust, and therefore it is a more commonly used steering mechanism.
Okay. So let us get back to our slide. Okay. So here you can see that there will be only one particular angle. Okay, angle of turning of vehicle where only this condition will be satisfied. That center of rolling of all four wheels is same, but at other angles, okay, these lines will intersect somewhere above this line. Okay, and as condition of steering will not be satisfied, what will happen? That rubbing of wheels on the road will takes place. Okay, but most of times what we do at whenever there is sharp turn, we slow down the vehicle. Okay, and because of slowing down the vehicle, we can control the wear and tear. It is the one reason that the Ackerman finds very wide applications. Mostly Ackerman steering is used because of mainly due to its simplicity, its construction. Okay, that makes it a popular choice. So as we saw that it is much simpler than Davis gear. It consists of only turning pairs. You can see that no pair is sliding, no pair is having any linear motion. As we have seen that it does not satisfy condition of correct steering at all the turning angles. But there are three positions where Ackerman gear provides correct steering. Okay. So first position is that when vehicle is moving straight. So no doubt when vehicle is moving straight, this center ICR will be at infinity for both rear wheel and as well as front wheel. So that time there is no problem. Condition of correct steering is satisfied. Second is when vehicle is turning at specific angle towards left. So in left there will be some angle of turning. You can say gamma. Okay. So if you uh, turn at that angle, at that particular angle gamma, okay, which will have a specific value, that time the condition will be satisfied. Similarly, when you will turn by the same angle gamma towards right, okay, condition of steering will be satisfied. So these are only three positions. Okay. So even if it is not mathematically correct in all the turning position, it is widely used in practice because of its simplicity. Okay, so it is about the Ackerman and Davis gear mechanism. Now let us see the next point or last point of our module 2, special mechanism, that is uh, universal or Hooke's joint. Okay, so I will clear all drawings. So it is also known as universal coupling or Hooke's coupling, universal joint. So earlier you have seen the Oldham's coupling. Why was where Oldham coupling was used? Do you remember in which situation Oldham coupling is used? Do you remember that it is the inversion of double slider crank chain, Oldham coupling? It is used to connect two shafts which are parallel and some distance apart. Their axes are not coinciding, not collinear, but some gap is there. You can see. So there we use the Oldham's coupling. It is also a coupling, universal coupling, or it is also known as Hooke's joint, as it was invented by Robert Hooke. Okay, after that scientist, it was named. It is used to connect two shafts which are intersecting at a small angle as shown in figure. Okay, so suppose it is the axis of one shaft and say it is the axis of another shaft. So these are intersecting shaft. Okay, say they are intersecting by a small angle alpha. Okay, angle of inclination of one shaft with second shaft. Okay, then you can connect these two shafts using the universal coupling. Okay, so what is the construction of it? Here, what is done? This Hooke's joint consists of one arm, sorry, one cross, which has two arm. One is horizontal arm and AB, and second is vertical arm CD. Okay, and each arm it will fit into the fork of each shaft. So, for example, you want to connect this driving shaft and this driven shaft. Okay, so what you need to do, that you need to make the end of the driving shaft in the form of fork like. So it is fork forked end like this. Okay, and this fork will have the bearings. Here you will have the holes in there. Similarly, driven shaft will also uh, be be having a forked end. इसका जो end रहेगा, it is in the form of fork, and it will also have the bearings holes. Okay, like this. Now what you need to do, you need to fit this cross into the bearings or holes of the fork end. So one cross, say AB, it will fit here into driving shaft like this, and the second arm CD, it will fit into the driven shaft. Okay, now when you will give motion to the driving shaft, as driving shaft will rotate, that motion will be transmitted to the cross, and cross will transmit that motion to the driven shaft. So this shaft will also start rotating, driven shaft. Okay, so it is also explained here like this. So you can consider it as shaft 1 and it is shaft 2. So shaft 1 is given this fork end. यहाँ पे ये shaft का ही part है, and same on that side. So इसका जो holes होते हैं bearings, उसमें ये cross fit होता है like this here, and the second arm of the cross fits into the second body. So as it will start rotating, it will transmit power to the second shaft. Okay, are you understanding it?
Yes, sir.
Okay, so but when you will imagine the motion of driving shaft and driven shaft, you will find that if even if driving shaft speed omega is constant, okay, but driven shaft speed omega 1 is not constant. Okay, sometimes ड्रिवन शाफ्ट का जो स्पीड होता है वो ड्राइविंग शाफ्ट से ज़्यादा होता है. ओके, समटाइम्स इट इज़ इक्वल टू द ड्राइविंग शाफ्ट, समटाइम इट इज़ लेस देन द ड्राइविंग शाफ्ट, and it all happens in one revolution. Okay, that is if shaft 1 will complete one revolution, at the same time shaft 2 will also complete the one revolution. But during this 360-degree motion, what happens that at particular angles, the angular velocity of the driven shaft will become greater than omega. Sometimes it will come to equal to omega, and sometimes it will be less than omega. Okay, so you will find that you do not get a constant velocity output using the Hooke's joint. Okay, and that's why it becomes kind of useless. Okay, but if we use the double hook joint, okay, by uh, introducing one intermediate shaft between driving shaft and driven shaft, okay, then it is possible to have the constant velocity output. Whatever variations are there, it will be observed by the intermediate piece. Okay, we will see that. Okay, so it will be understood in better way if you see a video of it. If any way I could show, I could on the voice of the video. You cannot hear the video, right? Yes or no?
Very soft, sir.
Can you hear it? The video, if I
So we
play.
cannot see the video.
No, no, no. I have no. I'm not playing now. But whenever I play the video, do you see the voice? Do you hear the voice?
Yes, sir, but it is very soft.
Okay. Okay. So I will increase the level of volume of my system. Then let us see. Okay. Let us. Now I will share you the video. Just a second.
Universal.
So when video is being played, okay, I have raised the volume of the system to highest. Okay, so I okay, I will adjust it. Share screen. Okay, now you can see it.
Joints are commonly used to transfer mechanical power between two shafts when their axes are at an angle to each other. Their invention dates back many centuries.
You can see a cross is there, which has two arms, vertical and horizontal. So this arm can also spin about its own axis. Okay, so this arm is free to turn about its own axis also like this. I will show you. ये जो है this arm of the cross can turn about its own axis also because it is in bearing. Okay, and here this can also turn about its own axis. So here this shaft is rotating, driving shaft, let us say driving shaft rotating at angular velocity omega. Like this, it is rotating. And this is nothing but driven shaft, output shaft, which is rotating at angular velocity omega 1. So what happens when this uh, driving shaft rotates with angular speed omega, because of the spin of the arm of the cross, this motion gets added in this or it gets subtracted from this. When it gets added in this, then you get omega 1 greater than omega. When it gets subtracted from this, you get omega 1 less than omega. Okay, further you see how it explains.
Even though the universal joints mechanism seems simple, the physics behind this mechanism are rather complicated and interesting. The universal joint has three basic parts: two yokes and a cross.
See, these are three basic parts. Yoke is we are calling it as fork. Okay, this is cross and it is again yoke.
Now, let's consider different power transmitting scenarios. In the first case, the input and output shaft are connected in a straight line.
See, it is the first case where input shaft and output shaft are connected in a straight line. There is no inclination. Okay, so directly power will be transmitted.
In this case, motion is really simple. The input shaft will turn the cross, and the cross will turn the output shaft. It is clear that both the input and output shafts will turn at the same speed.
They will turn at same
Now,
speed,
let's
right?
see-
Because directly power is getting transmitted. Okay, you have seen if you place a cross here, it is turning, and as it is in the same uh, line axis of this shaft, okay, it will also turn at the same angular velocity when shafts are collinear. It is the first case.
What happens if the axes are at an angle?
It is
Assume that
second
the
case.
input shaft is moving at a constant speed. Here, the motion is quite different. To understand why, just note the behavior of the red and